Hello Cloud Gurus and welcome to Domain 4 of the AWS Certified DevOps Engineer Professional course, Policies and Standards Automation. We're past the halfway mark, so congratulations on getting this far. This is the smallest domain in the exam, coming in at 10%. And this module covers more automation, but this time instead of systems, it's more referring to your AWS account and the policies and standards within it. We'll talk about optimizing your AWS account costs, as well as implementing services, which will help you govern the usage of your account. And just a note here that most of the lectures in this section are brief overviews, and they sit in the you need to know about it, and less in the you need to know exactly how to implement it. So there might be a few less labs than the other sections, mainly to save both you and I time on things that we don't need to know. Okay, let's get started. Hello Cloud Gurus and welcome to this lecture on AWS Service Catalog. This is a really quick one, so let's get started. Okay, so I'll just give you a brief overview of this service. So it enables organizations to create and manage catalogs of products that are approved for use on AWS. So you might only let a group of people use EC2 instances and that's it. They can't go to DynamoDB, they can't go anywhere else. It has an API that allows programmatic control over all end-user actions as an alternative to using the AWS console. So you can control everything your users are going to do via an API. And it also allows you to create your own custom interfaces and apps. So what this means is you can create a website, and on that website you can allow people to launch some EC2 instances, or they can launch a database, and they don't go to the AWS console to do so. You're creating your own custom interface instead of using that AWS console that you're so familiar with. Now, administrators of AWS Service Catalog can create and distribute application stacks called products. And products themselves can be grouped into folders called portfolios. And then your users can launch and manage those products without requiring access to the AWS services or the AWS console. So as I said, you can create your own interface and you don't have to use the Amazon one. And what this enables is the user only sees the products that they are supposed to see. You don't have a big confusing AWS console, you might just have a few drop-downs or a few buttons, and they can launch only what they're supposed to launch. So another angle of this is it enables all of your developers to spin up AWS services by themselves, while allowing the DevOps administrators to control the configuration of those resources. So this ensures compliance to your company policies and the standards that are set because you only let them provision what you've already approved to be compliant. Now, there's very little about this service that you need to know beyond what I've just told you here, so I won't be providing a demo. And it's also pretty difficult to show as making your own interface to the AWS console can take quite a lot of work and you don't need to know how to do that for the exam. However, in the resources link for this lecture, there's a very quick demo from one of the developers from AWS, which quickly runs through it if you'd like to have a look. All right, thanks for listening. If you have any questions, please let me know. Otherwise, feel free to move on to the next lecture. Hello, Cloud Gurus, and welcome to this lecture on AWS Trusted Advisor. So what is Trusted Advisor? Well, it's a service that provides you with real-time guidance to ensure your AWS resources are provisioned and managed correctly and are following AWS best practices. So let's expand on that a little bit more. It has categories and it provides a report for these categories, which will give you an overview of your AWS account. And this gives you an idea of what needs to be fixed or changed if there are any issues. So firstly, there's cost optimization, which lets you know if you're paying too much and shows you places you can save money on your AWS bill. And that's kind of nice from Amazon. Usually a company would want you to pay more, but they help you pay less. There's performance, which will tell you about your service utilization. Are you underutilizing your resources or could you scale back something? Then we have security, which will let you know about ways to tighten up security on your account and if you're missing anything. So you could have some security groups which are allowing access to everyone in the world and it'll let you know about those. Then it has fault tolerance, which will let you know how ready you are for an incident by looking at things like the age of your current snapshots. And then we have service limits, which will tell you how close you are to breaching service limits on your AWS account. So are you close to breaching the amount of policies that you've got in place and so on. Now, some of these reports are free and some you have to pay for, and which ones you get depend on your AWS support plan on your account. So let's have a look at those quickly. So as you can see here, the current AWS support plans, Basic and Developer, get access to 7 core Trusted Advisor checks, and the Business and Enterprise accounts get access to all Trusted Advisor checks. All right, time for a quick demo. Let's head on over to the AWS console to take a look. Okay, I'm in my AWS Management Console and I'm going to go to Trusted Advisor. I actually don't know what I'm going to find here. Okay, so there's a few things here, mostly green, but we've got 2 actions at the top under security. So you can see we've got the recommended actions here. So MFA on our root account is our highest recommended action, which is the quickest way to really lock down your account. So it checks the root account and warns if multi-factor authentication is not enabled. Then it talks a little bit about security groups. I've got certain ports which are unrestricted and the rest is all generally green. So we're using IAM, S3 bucket permissions are pretty good, EBS public snapshots, RDS snapshots, and that's all good. So let's click through one at a time. And there's a reason we're only seeing 2 of these. Cost optimization, you have to upgrade your support plan to unlock all Trusted Advisor recommendations. So this is what I said, you only get a few of them if your support plan is just the basic one. But you can see what it would unlock. So it will tell you if you've got idle load balancers or low utilization on your EC2 instances, underutilized volumes, unassociated elastic IPs, which all cost you money. And it's a really great way to find out ways to actually save money. You could actually just look at these topics and go through and check them manually yourself as well. Go to performance. Again, it's locked down, but it'll tell you if you've got high utilization on EC2 instances, if you need to scale something up or down. If you've got a large number of rules in EC2 security groups and overutilized EBS magnetic volumes and things like that. Security is the one that we do have access to. So it said we've got 7 checks. So it looks like we've got 6 of them here. MFA on the root account, your security groups, some snapshots and permissions and IAM use. We'll look at fault tolerance. It's another lockdown. But it'll tell you the age of your EBS snapshots. So this is the fault tolerance where it's actually telling you how prepared you are for a disaster. Have you got VPN tunnel redundancy? It checks the availability of resources associated with your launch configurations and auto-scaling groups, how your backups are going, cross-zone load balancing, and all these kinds of things. And then we've got service limits, and it looks like this one is available for all. So it tells you if you're close to breaching your service limits. So you can click through these and you can get a bit more information about them as well. So let's have a look. DynamoDB write capacity, read capacity. There's quite a lot here. So without upgrading my plan, that's pretty much all I can show you for Trusted Advisor. It's a great little service out there to help you save money, improve your performance, optimize your costs, which is kind of the same as saving money, improving your security and making sure you're not going to breach your service limits. All right, that's about it for this lecture. Thanks for listening. If you have any questions, please let me know. Otherwise, feel free to move on to the next lecture. Hello, Cloud Gurus, and welcome to this lecture on AWS Systems Manager. So, what is it? Well, AWS System Manager is a management service that assists with collecting software inventory, applying OS patches, creating system images, configuring operating systems. You can manage hybrid cloud systems from a single interface, both AWS and on-premises machines, and it helps with reducing costs. So that's a whole lot of things that it assists with, but how does it actually do it? Well, it has a whole bunch of features all rolled into one AWS service in your console, and it comes with the following features. It has a run command feature, which provides you with a safe, secure remote management of your instances at scale without having to log into the servers. It provides a way to automate your administrative tasks. It'll go off and connect to all of your instances for you, and it can run the commands on your behalf. And this works with SSH or remote PowerShell as well for Windows servers. It has a state manager, which provides configuration management, which helps you maintain your EC2 instances so they're consistent. So it'll let you control configuration details like firewall settings, antivirus definitions, and things like that. It can automatically apply your configurations across all of your instances at a time at a frequency that you specify, or you can do it in groups. So if you've got a set of instances to do one task versus a set to do another task, you only apply it to certain ones. It's got an inventory manager, which will collect information about your instances and all the software installed on them, which helps you get an overview of all your systems and the installed applications. And you can collect data about applications, files, network configurations, server roles, and all these other system properties. We've got maintenance window support, which lets you schedule a window of time to run all your administrative and maintenance tasks across all of your instances. So this is so you don't interrupt your business day to day. You can do it between 2 and 5 a.m. if you like, and it won't affect anything. There's a patch manager, which helps you select and deploy operating system and software packages automatically across all your EC2 instances. And that's really useful as well, and it'll save you heaps of time. And we've got automation, which is a service that allows you to safely automate common and repetitive IT tasks. And it also comes with a parameter store, which is a centralized place to store and manage your configuration data, whether it's plain text or database strings or secrets such as passwords. And this allows you to separate your secrets and configuration data from your code. Parameters can be tagged as well, and they can be organized into hierarchies, which helps you manage them more easily. Okay, so as always, it's best to go see what this looks like in the console. Let's go open our AWS consoles and take a look. Okay, so I'm here in the AWS Management Console, and we're going to type System Manager. So here's our Systems Manager console. This shows we can gain operational insight and take action on AWS resources. Now we will have to set this up the first time we use it, so click on Get Started with Systems Manager. Now there's a quick setup. It's not too hard to do. We're going to use the default role and the default assume role. We have some options here. So I'm going to update Systems Manager agent every 2 weeks, collect inventory from your instances every 30 minutes, and we'll scan instances for missing patches daily. We can also install and configure CloudWatch if we like, and we can update the CloudWatch agent every 30 days too. And this will all happen automatically for you. Now we also have targets we can select, which we're going to manage with Systems Manager. And I'm going to choose all instances in the current AWS account and region. You can also do it by tag or choose your instances manually. So let's click on Setup. Now that'll go off, and it will do all the configuration that it's required, and all of these are in pending except for this one. So I'll give that a few minutes and then we'll come back to this when that's done. Okay, we are back and everything is success except the 2 bottom ones which aren't configured, which is fine. But all of these are green, which is great. I did have one issue with this one sitting in pending. All I had to do was reboot the machine. For some reason, the SSM service, which was installed on the Linux machine, bugged out a little bit. And of course, a reboot fixes everything. So if you have the same issue, you can see if that helps you out. Now, Systems Manager is a really complex service and it supports a lot of things. So I'm just going to click through a few things to show you the important ones that you probably need to know about for the exam. In my experience, I probably only got 1, maybe 2 questions on this, so it's probably not worth going too deep in it. So let's start over here, and we have the managed instances. And this is going to list everything that Systems Manager is now managing. And you can see here, I have my one EC2 instance. It's picked up that it's Linux, Ubuntu, we've got the agent version, IP address, and the computer name. And if it associated successfully, which it did, and you can click these quick links to go straight to AWS config and the EC2 instance itself. So you can see here, it shows me my instance. And we haven't configured AWS config in this account, so nothing in there just yet. Now there's one other thing that I need to tell you. When you're managing instances, you can also manage on-premise instances. And I had a question dedicated to this, which asked me what was the prefix for an on-premises instance instead of an EC2 instance. So EC2 has this I hyphen. If you are asked in the exam, any on-premise server or a virtual machine which is managed by Systems Manager has an MI prefix. So it's MI dash instead of just I. And you can remember that because it's a managed instance, MI. If that doesn't help you remember it, well, just remember there's a managed instance and then EC2 always uses the I just by itself. So make sure you remember that. It's probably worth 1 or 2 points in your exam if you get that question. So let's have a look and see what we can do here. If we go to inventory, So this is our dashboard in inventory. It just gives us a bit of an overview of what is being managed. So we've got some AWS components, an AWS application, we've got some network, but there's no Windows registries or roles or Windows updates being managed by this service. Now we've already been to manage instances. I don't believe we'll have anything useful in hybrid activations. So this lets you register an on-premises server or device with System Manager. So you can see here how it works. You've got to create an IAM service role, get the agent installed, and then you can manage it through here. We have a Session Manager. Session Manager is a managed service that lets you secure your instances without having to go and edit all your security groups or your VPC inbound and outbound rules. So it says here you can do a one-click secure access to your instances, which is awesome. And it's used to improve security. You can centralize your access control to all your instances, and you can get some detailed audit records as well. And it's cross-platform and supports VPC, which is cool. So I won't go too far into that. Run Command is a very cool service. It lets you run commands across all your instances at the same time and get the results of them. So let's see if I can do this. So let's try platform types is Linux. And then we're going to find AWS run shell script, that one. That'll open up in a new window. We can leave these defaults. We'll click on Run Command. And we can specify our parameters here to run. So I'll just run something really simple. I'll just run the date command, and this should get us our date. Now you can specify what you want to run this on. If you want to run it on everything, or you can specify via instance tag. You can do it manually, so you can pick your instances, or you can choose a resource group if you've created one. So you might have a group just for your Windows machines, just your Linux machines, or just your dev or your prod, things like that. So I'm just going to do the easy option, choose instances manually because I only have one anyway. And we can write our result to an S3 bucket if we like. Let's just pick ECG DevOps and we'll prefix it with SSM. And that's it. Let's try that. We'll run it. It should go off and run that date command and then store the result in S3. So I'll quickly bring up S3 from my shortcut. And let's go into the bucket. Where are we? ECG DevOps. SSM. That's the instance ID. It ran the shell script. And we have a standard out, which should be the reply. Now let's just open it here. We shouldn't have to download it. Oh, access denied. Let's make it public. And then open the URL. And there we go. There's the date from the system. Apologies for it being so small. There we go. Awesome. So that lets you run commands across all of your instances. You can get the output in S3. Really cool way to run something if you need it done on all of your systems. If I F5 this page, this should all be done. Yep, success, success. Awesome. So that's how run command works. Really useful for the reasons that I mentioned. Now we can look at State Manager. Now, State Manager is a service that automates the process of keeping your EC2 and hybrid infrastructure in a state that you define. So you can bootstrap instances at startup, you can configure network settings, you can download updates on a schedule, and you can patch instances and all these kinds of things. I won't go into it, but just know that it's possible. And I'll link over to the documentation as well, just so you can have a quick read through and see what else can be done. Now we also have the Patch Manager, which I think is pretty self-explanatory. It provides automated patching with a native AWS solution. You can create patch baselines for each operating system, or you can use the default patch baselines that it comes with. You can have approval rules, so you can make sure people have to approve patches before they're deployed to all of your systems. And you've got compliance as well, so you can see which machines are compliant or not based on their current patch level. So other things I'll just show you quickly. We've got maintenance windows. You can specify your maintenance windows. You can also schedule regular tasks, such as your patching, to run automatically. And you can set limits for that as well. And it also lets you run some complex tasks. So automation workflows, AWS step functions, and Lambda functions. There's just so much that this service can do. All right, now I believe that's all you need to know for the exam. Of course, if you have time, click through every menu on the side here and check out the documentation as well. There's some use cases and some FAQs, which are always awesome to read. Okay, so thanks for listening. If you have any questions, please let me know. Otherwise, feel free to move on to the next lecture. Hello, Cloud Gurus, and welcome to this lecture on AWS organizations. So here is our brief description. AWS Organizations offers policy-based management for multiple AWS accounts. What does this mean? Well, it's a way to manage policies across all of your AWS accounts from a single service. A large organization will usually have more than one AWS account to help manage costs, security, and their resources. They can split their accounts in many different ways, such as environments where you might split it into prod, dev, and test, or you may split on the project, where Project 1, Project 2, and Project 3 will all get their own AWS account. Or you may even split it by business units, so the sales have an account, support has an account, and developers get their own accounts as well. So AWS Organizations helps you manage all of these accounts from one central place, and it has a few other features as well. It lets you programmatically create new accounts. It'll let you create and maintain groups of accounts, and you can set policies on those groups. It's kind of like IAM, but Organizations overrides what IAM can provide. Your IAM policy might allow you to spin up EC2 instances, but if the organization policy applied to your account doesn't let you spin up EC2 instances, then you're unable to. So it's kind of an overriding policy holder, which controls what you can do in each one of your accounts. Now, what we're going to do is see if we can set this up with two AWS accounts that I just created. They're just test accounts, they're brand new. Feel free to follow along or to do this yourself if you like. All right, let's jump on over to the AWS console to get started. Okay, I've got two accounts here. This is DevOps 1, and if I Alt-Tab, I've got DevOps 2. So this is in my normal Chrome session, and this is running in my incognito session, just so I can be logged into both at the same time. Now I'll get this one in Sydney, just so we're in the same region. And now they're both in Sydney. Cool. Now I'm going to make DevOps 1 the master. So let's go to AWS Organizations. Now I'm going to create an organization. So this is the console here. You can create an account, organize them, and then apply policies across them. If you're already in an organization, this won't look like this for you. And this is why I'm using test accounts, because my main account is already in one. So let's create. It creates an organization that provides single payer and centralized cost tracking, lets you create and invite accounts, allows you to apply policy-based controls, and helps you simplify organization-wide management of AWS services. So let's create. Okay, so it's sent me an email to my email address that I've used for this, and I'm going to go and verify that, and then I'll jump back here. Okay, I clicked my link from my email, and it says your email address has been verified. You can now invite existing AWS accounts to join your organization. So I'm going to add an account. I could have created an account right here, but I'll invite an account. The email is going to be nick plus devops2 at acloud.guru, and we'll invite. Now I'll go and check my email, and I'll click on that link in my other browser. So let's Alt-Tab over to here. Now we'll go to Organizations. And you can see here, invitations, I've got a 1. So let's click on that, and I have been invited to join another organization. It requests that we enable all features, and the master account is going to pay for charges accrued by all the member accounts. Awesome. So let's accept that. I'm going to join this organization, confirm. Great, my account now belongs to the following organization. So in my DevOps 2 account that you can see up here, I can't do anything else. This is all managed by DevOps 1, so I'm just going to get rid of this and we won't see it again. You can leave the organization if you like. Okay, here's organization 1. Let's go to accounts. We have two accounts here. We've got the primary and the secondary account here. Awesome. So we've got an organization going. So here are our accounts. So we've got DevOps 2 and DevOps 1, and we've got a tree view if we create one. Now let's create an organizational unit. Let's call it development. We'll create that. So let's click on an account, OU. We want to move account. All right, so we'll click on move. We'll move it into development and we can move that. Now we can click on DevOps, move that. and that can be in development as well. So now we have no accounts in the root, but if we go into development, we can click on accounts and we can see we've got 2 in there. So you can create this tree view of all your accounts. So even under development, we could make a new OU called test. We could create one called unit tests, create one called dev, and so on. So you can create this tree however you like. Now I might move DevOps into unit tests. So DevOps 1 and DevOps 2 can be moved straight into the dev OU. Okay, now we can go look at policies. Let's create a policy. You can generate a policy or copy an existing policy. Let's have a look. Select the policy. Oh, that's full AWS access. Policy generator. Let's deny EC2. Deny EC2, so choose an overall effect. We can deny or allow something. So I'm going to deny everything in Amazon EC2. Select all, add that statement, and then create policy. Okay, so we've got full AWS access, which allows access to every operation, and then we're going to deny EC2. Now we can apply this to an account or an organizational unit. So let's look at OUs. This policy is not attached to any OU. To attach it, go over to Organize Accounts. Let's go to the root, and we want to enable some policies. We've got service control policies here. Full AWS access is enabled already, and let's attach the deny EC2. Oh wait, let's detach that first, and we'll just attach it on a single OU. How about unit tests? We won't let anyone in unit tests spin up any EC2 instance. Okay, so this means everyone else can spin up EC2 instances, but the unit test accounts cannot. So what I'm going to do, I can't even remember which account I put under unit tests. DevOps 1. So this account we're in shouldn't be able to spin up any EC2 instances. So let's see if that worked. I'm going to jump over there and have a look. So EC2. Let's launch. Select anything. Launch. No key pairs. It's fine. Okay, that's creating, so it didn't work, and I'll show you why. Now the best way to figure out why things don't work is of course to come to the documentation. So let's have a look at this quick policies documentation. A policy applied to a root applies to all accounts in the organization. A policy applied to an OU applies to all accounts in the OU and any child OUs. And a policy applied to an account applies to only that one account. And one thing to note here, service control policies never apply to the master account, no matter which root or OU the master account is located in. So I had applied this policy to the OU, which had DevOps 1 in it, but DevOps 1 is the master account, so that's not going to work. So let's go and try it on DevOps 2 and see what happens. So DevOps 2 has the policies, full AWS access. Let's attach deny all EC2. Let's detach AWS full access. Oh, we didn't even need to attach that, but it needs one attached anyway. So it's got deny all EC2 and deny all EC2 from development and root. So I'm going to jump over to DevOps 2 and I'll see if that can create anything in EC2. Okay, back on DevOps 2, let's go to EC2. Oh, and here we see the policy working. I'm not authorized to even describe my running instances, let alone click launch. Although we can click launch, but we can't even describe the AMI. So now it looks like it's working. The master account gets full access to everything, and it's all the children accounts which you're applying policies to is where the restrictions come in. So I probably shouldn't have done that, but it's a learning experience for both of us. The master account gets to do everything, and everything else is restricted based on your policies that you define. So that's about it. I don't think I have to go into much more with AWS organizations. The only thing might be the settings here where we've got this trust for AWS services. So this allows other AWS services to perform actions in this organization. A trusted service can access information about the accounts, the root, the OU, and the policies. So there's a few services here that work with organizations. So single sign-on, license manager, service catalog, directory service, and artifact and things like that. All right, thanks for listening. If you have any questions about this, please let me know. Otherwise, feel free to move on to the next lecture. Hello Cloud Gurus and welcome to this lecture on AWS Secrets Manager. So what is it? AWS Secrets Manager is a service to help you protect secrets needed to access your applications, your services, and your IT resources. So let's take a look at the features. It encrypts secrets at rest using your own encryption keys that are stored in KMS. Secrets can be database credentials, passwords, third-party API keys, or even any kind of text that you want stored securely. You store and control access to them with the Secrets Manager console, the CLI, the API, or the SDK in your own code. Hard-coded credentials that you might have in your existing source code is replaced with a simple API call. So it's a lot more secure than hard-coding all these credentials in your source code. You store them somewhere else and you just make a call to grab the password when you need it. And the secrets can be rotated automatically according to your own schedule. Now let's take a look at an example to show you how this works. We have an administrator who creates a set of credentials on a database for his or her application to access. The administrator then stores those credentials in AWS Secrets Manager in a secret called MyDBPassword. When the app needs to access the database, it queries Secrets Manager and it asks for the MyDBPassword credentials. The Secrets Manager then retrieves, decrypts, and sends the secret back to the app via a secure channel, which is HTTPS using TLS. The client app then passes the credentials and uses that to access the database. So it's a fairly simple process and a simple service. It's not too technical, so that's about all I can tell you about it without showing you. So let's head on over to the AWS console to see what it looks like. Okay, we're in our console. Let's take a look at Secrets Manager. Okay, easily rotate, manage, and retrieve secrets through their lifecycle. Okay, we can get started by clicking Store a New Secret. And you can see here we have 3 different secret types. We have credentials for RDS database, credentials for other database. You can see MariaDB, MySQL, Postgres, Oracle, and SQL Server. And other types of secrets. So this is where we can put in a secret key value pair or just some plain text. But we're going to test this out by using RDS database. We'll put in a username, my username, and password. Okay, now I'll just click show password. We just want to store my username and blah blah. We're going to use the default encryption key that AWS KMS is using, and down here you need an RDS instance active to be able to select one. So I just created one for this lecture. Click on next. We can call it MySQL password for my database. No tags. Click next. Oh, no spaces allowed. Now this is a feature that I haven't mentioned yet in the slides, but Secrets Manager supports automatic rotation of passwords when using a supported AWS service. So that means it's automatically going to change the password and store the new password in Secrets Manager, and it'll change it on the service as well, so RDS. And then within your application, because you're not hard coding anything, it's just going to keep working, but it's more secure because it's constantly being rotated for you. And if anyone gets their hands on your credentials, it's most likely already been rotated out. So I could enable automatic rotation, and you can do this every 30, 60, 90 or custom days. So you could do it every day, which is kind of ridiculous, but it's possible. And it creates a Lambda function to perform this for you, or you could select an existing one. And then you select which username and password will be used to perform the rotation on the service. So either this one you're defining or one that you've previously stored in Secrets Manager. So let's just disable that and click next. This is where you review. And something awesome here, we are given sample code on how to use it. So we'll jump on Python, and I'll actually show you this in a better interface in a moment. So let's click store. Now MySQL password is stored. You can come in here and have a look. Now what I'll do is I'll bring up the code just to show you how we would access this. So I'll bring in my code window here. And you'll see it uses a bit of Boto and base64. And you'll see it's got a few imports and then this defined get secret function. So your secret name will be MySQL password. My region name will be the region we're running in, which is AP Southeast 2, Sydney. And then it creates the Secrets Manager client. It tries to get the secret value response from the client. and it's saying secret ID is the secret name that we defined, which was the one up here. It catches the exceptions if there's any errors. Otherwise, it decrypts the secret using the associated KMS key. Now it says here, depending on whether the secret is a string or a binary, one of these fields will be populated. And then after that, you can just use your secret. So you will connect to your database here, or you'll be able to use your encrypted text or something with those key pairs that you stored securely in Secrets Manager. So it's really quite easy to have this secure way to store your authentication credentials within the AWS service. Once it's set up, you don't even have to bother with your credentials anymore, which is really awesome. Okay, so that's what AWS Secrets Manager does. If you have any questions, please let me know. Otherwise, feel free to move on to the next lecture. Hello Cloud Gurus, and welcome to this lecture on Amazon Macie. Amazon Macie is a security service that uses machine learning to automatically discover, classify, and protect sensitive data in AWS. Now, I don't know about you, but that sounds pretty amazing to me. Let's check out some of the features. So this is a managed service, and it has the ability to recognize any personally identifiable information or intellectual property that exists in your data. It gives you a dashboard which shows you how the data is being accessed or moved, and it monitors any of this data access for anomalies. And it will generate detailed alerts when it detects a risk of unauthorized access or any accidental data leaks. Now, it currently only protects data in S3, but more AWS data stores are planned for the future. It gives you superior visibility of your data, and it's simple to set up and easy to manage. Now, we're going to jump over to the AWS console to try this out because there's not much more I can tell you about it, although I'm not too sure if I have anything in S3 that might be risky. So let's go and take a look. Okay, let's find our service. Okay, let's search for Macie. There it is. Now its interface is a little bit different to everything else in the AWS console, and it only seems to run in two regions, North Virginia or Oregon. So let's click on Get Started. So we can select the region and service permission. So when we enable Macie, it's going to grant Macie permission to look in all of your data. So you can view the service role. It's going to give access to CloudTrail, IAM, and S3. And you can suspend or disable at any time to stop it from classifying and processing your data. So let's click Enable. Okay, so we're loaded here, and this is our Macie UI. We've got critical assets, which are of high risk, and that's not available. Total event occurrences, not available, and total user sessions is not available. And we don't have any IAM users defined either. So in here, you've got a slider where you can change your minimum risk of what you want to see. So if you want to see everything, minimum risk can be 1. If you only want to see the really high priority things, you can look at 10. So there's no results that match your search, most likely because I said I don't have much in my S3 accounts. You can have a look at your alerts here. We've got basic and predictive alerts. We've got our users defined here. And you can use this research page to construct and run queries to investigate your Macie monitored data. So like I said, there's not much I can show you, but this is the Macie dashboard. You can also click through to S3 objects, objects by ACL, activity location, CloudTrail user identity types. So if you're in the game of having lots of data in S3, potentially sensitive data, medical records, things like that, this is really going to tell you where that data is being used and if you need to secure it any more than you are already. All right, that's all you really need to know about Macie. In the exam, I don't think it came up very much. It might have been a possible answer on 1 or 2 of my questions. So now you know what it does and you can make an informed decision as to whether you're going to pick that answer or not. All right, thanks for listening. If you have any questions, please let me know. Otherwise, feel free to move on to the next lecture. Hello Cloud Gurus, and welcome to this lecture on AWS Certificate Manager. So what is it? Certificate Manager is a service which lets you easily provision, manage and deploy public and private SSL and TLS certificates for use with your AWS services. Let's take a look at some features. It allows you to centrally manage your certificates in AWS, and you can audit the use of each of your certificates in CloudTrail logs as well. There's also a private certificate authority available, which is a managed private certificate authority service that lets you manage the lifecycle of your own private certificates. This is really useful for internal certificate usage. It also integrates really well with other AWS services, so you can provision certificates and then deploy them with CloudFront, API Gateway, or even in your own Elastic load balancers. And finally, you can import your own third-party certificates from other certificate authorities that you may be using. So that's about all you need to know. Let's see if we can create a certificate and then use it in another AWS service like a load balancer. Let's head on over to the console to try it out. Okay, let's have a look at Certificate Manager. Okay, here we are. We have two options. We can provision a certificate or we can look at the private certificate authority. So as I said, this service is for issuing and revoking private digital certificates. So they let you identify and secure your applications, services, devices, and users within your organization. So I don't think I was asked, but if you are asked about anything about private certificates, AWS Certificate Manager is where you would be managing them. Let's try over here. We'll create a certificate ourselves. We can request a public or private. I'm going to request public. Private would be enabled if you went to that other option already. You can also import your own certificates as well. Okay, so you can type in your domain name. Now I'm going to use a sample domain that I own. Let's try acat.guru. We'll click next. Now I'll use DNS to validate this. We'll click review and we'll confirm and request. Okay, so we need to create a CNAME to verify this. So I'm going to load up Route 53 and I'll get this done. Okay, this is our name. And I'll create a record set. It's going to go in there as the name. It's going to be a CNAME. And this is going to be our value. Now, before we finish this, I just want to click on this and come to the end. Yep, we got ACAT Guru in there twice. So delete that and then we'll click create. Now this can take up to 72 hours to validate, so I'll just pause it here and I'll come back when it's done. Okay, we're back and our status is issued, which means we have validated our domain. So now what I'm going to do is jump over to the EC2 console. Let's create a load balancer. Create. We'll do an application load balancer. Internet facing. We're going to make it secure. We'll select all zones, configure our security settings, and we'll just call it test. Now, certificate type, we can choose a certificate from ACM, which is recommended. So that's our Amazon Certificate Manager. And you can see it's already populated here with the acat.guru certificate. Awesome. So we'll click next, next, target group. We'll just make a new one. We'll call that test as well. Target type instance. This is all fine. Register our targets. I'll just select this instance that I've got running. We'll click review, create. Our load balancer test was created. Excellent. So this is now created and it's using our acat.guru certificate. Awesome. So that's how AWS Certificate Manager will let you create a certificate. You authorize it to use your certificates and it will manage them all for you. And that's pretty much it for this service. All right. Thanks for listening. If you have any questions, please let me know. Otherwise, feel free to move on to the quiz.